All right, today we are reviewing for a test. It's the Adams test. I really do not. Okay, we are moving ahead and I'm highlighting where my mouse is. I didn't want to do that. All right, we're doing the Adams test. You should have a periodic table when you are taking a test about atoms. Periodic table. And here we go. According to the chart, which element is most essential to our planet? So to find the most essential one, I guess they want most important. So that would be, you would look in the different parts of the earth, the crust, the atmosphere, the ocean, the organic material or living things, and you would see which element is in all of those places. So obviously it's oxygen. So that's the answer. That's how you do it. Bethany's using chemical formulas for various substances to classify them as either a compound or an element. A compound is more than one element combined together with chemical bonds. An element is a pure substance that cannot be broken down into more than one substance. So let's look at the choices. Which of the following should Bethany classify as a compound? Methane, CH4. Well, if you looked on the periodic table of elements, you could not find methane. It is not an element. It's made of carbon and hydrogen combined together. So therefore, it is a compound, and it is the answer. However, should you just pick the first thing and you think it's right and look at it without looking at the other ones? Oh, no. Should never do that. Go ahead and look at the other answer choices. We have carbon, which you can find on the periodic table of elements, so it's an element. Silicon, same thing. Silver, same thing. It's on the periodic table of elements. It's an element. Its symbol is Ag. It's only one thing. It has a capital letter and lowercase letter. You know that's a symbol for one type of element. So the answer is methane. Moving ahead. During a game, students were asked to select the correct symbol with the element. To select the correct symbol with the element. So we're putting the element with the symbol that match together, just like on the periodic table. All of the following answers would be correct except, so you should circle that. It's very important when you have except or not in the question. So we're matching them. So I'm thinking that you'll have your own periodic table in your own little hands that you can look at. So I'm not expecting you to see this. I just put it there to show you that you should use a periodic table. Sodium is Na, and if you looked around on there, you searched everywhere, you could find Na and it says sodium. So that's a match. So it's not correct because this says except. H, helium. H, it says hydrogen on here. Helium's over here, it's He. So this looks like it's not a match. It doesn't go together. So since we're looking for the wrong answer, that would probably be the one we pick. O, oxygen. So we need to look for it. Here it is. And O means oxygen, so that's a good match. C, carbon. Oh, where is it? Here it is, C and carbon, so that's a match. So I'm looking for the one that's not a match, and that is H, helium. So that's the right answer. Jane saw the letter P on a container in the science lab. Which element was most likely found in the container? Well, it's a science lab, so maybe they're using the symbols on the periodic table. So P on the periodic table, which you, of course, would take the time to get out your periodic table and look at it. We're not going to be lazy test takers. You would find that P does not stand for peroxide, nitrogen, or sodium. It stands for phosphorus. Phosphorus. The instructions for a lab warned students to avoid putting Na, capital N, lowercase a, so that's a symbol on the periodic table, in the liquid used during the experiment. What element should not be placed in the liquid? So it's whatever element this is. And the answer choices would have the names of the elements. And so you would have to search everywhere and find Na and then pick that name. It's sodium. Which item listed below is not considered an element? Not an element. Well, this is the periodic table of elements, so you could search for all these, and whichever one is not on the periodic table, then you could choose that for the answer. Calcium, water, phosphorus, and sulfur. You might already know from paying attention in class that water is made of hydrogen and oxygen. It's a compound. So you would already know that water is correct without having to search everywhere. But if you did search everywhere, you could see calcium and you could circle it, say that's not right. You could look for water and you're like, man, I don't see it anywhere, but it might be there and I missed it. Phosphorus, you're looking everywhere. Where is it? Oh, you find it, so you know that's not right. And sulfur, you look everywhere and you find it, so you know that is on the periodic table of elements, so it is an element. So calcium, phosphorus, and sulfur are elements, but we're doing not considered an element. So you should circle the word not, just like you did the word except, and then you would choose water. Which is the smallest quantity of an element? This is a definition type question. So the smallest quantity of an element is called an atom. It's just the definition. There's no other really way to figure it out. You just have to know the definitions. What terms correspond to X and Y in the table? So we have X and Y. So we read about X, we read about Y, we look and see what the answers are. X contains only one type of atom, so already you should know what X is. And electrons act independently, and it can exist as molecules. That's an element because it's only one type of atom. Contains more than one type of atom, so that's going to be a compound, and it shares electrons, and it only exists as molecules. So we have X is elements, Y is compounds. So we just have to match that up, and it's G. Which of the following diagrams illustrates a compound? So really, I don't know why this other part of the question's there, but it makes it very easy. But even if you didn't see one oxygen and two hydrogen, you could answer this. And a compound is more than one substance. This A definitely has oxygen and hydrogen, so it's more than one substance. So that would be a compound. This is all carbons. Letter C stands for carbon, so it's all the same substance, so it's a compound. It's an element. And here it's an atom, so obviously it's only one atom, so it's only one type of thing. So this is lithium, but it's an element. And D says not the answer. So if you ever pick not the answer, that's going to be wrong because it's not the answer. Helium gas is an element and not a compound. Why is this true? Well, it's a definition question. What is an element? An element is a pure substance that cannot be broken down. So helium gas consists of a single pure substance is correct. Being light doesn't make it an element. Not being used in industries doesn't make it an element, and that's not even true. And helium gas has a low atomic number, and that doesn't make it an element. You could have a high atomic number and have it be an element. So J doesn't make sense either. An element is different from a compound because, all right, what do we know about elements? They're a single pure substance. A compound is more than one substance combined with chemical bonds. So we know that, so we have to just find the answer that matches it. An element is highly reactive. Well, that's not what makes an element an element. There are some elements that are totally non-reactive, so A is not correct. Compounds contain a maximum of one or two pure substances. Well, it could actually have a lot more than just one or two, so that's not right. An element contains many. Well, that's definitely wrong. An element cannot be broken down into simpler substances. That's true. And a compound can. That's true. So C looks good. A compound is composed of only one pure substance. That's not what a compound is. That's already wrong. And an element is composed of more than one. Well, no, that's not right. that's mixed up. So it's C. Sam's mother is cooking breakfast in a cast iron frying pan. If the pan is made only of iron, what can Sam conclude? Okay. Iron is a pure substance with a chemical symbol I. How could you know what the chemical symbol is if you don't look at your periodic table? You would never know unless you have it memorized. So you're going to need your periodic table here. Iron is a pure substance with chemical symbol F. Iron is a pure substance with chemical symbol Fe. Iron is a chemical substance with chemical symbol capital F, capital E. Well, out of these, only J is something I can definitely throw out because we know that there are no chemical symbols with two capital letters. So J definitely is wrong. And then to find the right answer, you have to find iron on the periodic table, and then you would see which symbol matches it, and it's Fe. The second most abundant element in Earth's crust is silicon, which is a pure substance with the symbol Si. Well, it's an element, we already know, so that's a pure substance for sure. But what is the chemical symbol for silicon? How do you find out? You look at your periodic table. Don't be a lazy test taker. Get out that periodic table. Look at it. Find silicon on it. See what the symbol is. And then you would know which one it is. It's the simplest kind of question. You just have to not be lazy about it. Using the chart above, I love this kind of question when I take a test because all the information to get it right is given to you. You don't have to know anything. You just have to be able to look at the test. Which gases make up the majority of Earth's atmosphere? I covered up the question there. Well, the majority is, what's the majority is the most. So the most is 78 and 21, and it goes down. Look, they have it in order. What could be simpler? So the answer would be nitrogen and oxygen. Maybe they would include argon. They might include argon in there, but definitely the answer would have to be including nitrogen and oxygen. Okay, wow, we got lots of graphs on this question. Which element is found in relatively high abundance in the human body? Human body, here it is, as well as Earth's oceans, crust, and atmosphere. So we want to know what's in relatively high abundance. So abundance means there's a lot of it. So high abundance, there's a whole lot of it. So we want something that's in high abundance in every one of these graphs. So in every one of these graphs, what is there? Pretty big amount, relatively high. So here the biggest ones are oxygen, silicon. Here oxygen and hydrogen, really it's only 11% basically. So oxygen seems like the main thing in the ocean. And in the human body, we have a lot of oxygen and carbon. And then here in the Earth's atmosphere, we have a lot of nitrogen and also quite a bit of oxygen. So of these, which one's in all of them? Just like the first question we looked at, it's oxygen. So I'll just mention, though, that in Earth's ocean, all the oxygen, well, actually, this isn't true. So, a lot of the oxygen is actually in the water, H2O, so water contains oxygen, but there's also oxygen gas dissolved in the water. So there's the water, plus there's oxygen in the water, so lots of oxygen in the ocean. The most abundant element in Earth's atmosphere is, and they give you a graph. So your job, just like this fellow here, is to look carefully at the graph to find the answer. The most abundant. Which one is the highest? Nitrogen. All right, the acronym CHNOPS, or CHNOPS, is often used to help students remember the most abundant elements in living organisms. Using the periodic table, which elements are represented in CHNOPS. So we're looking for C, carbon, H, hydrogen, N, and of course You might have to look around a little bit, but it's nitrogen. O is oxygen. P is phosphorus. S is sulfur. So those are the answers. You would look for an answer. You'll have multiple choice, but the answer is going to be carbon, hydrogen, nitrogen, oxygen, phosphorus, sulfur. So you just have to match it up. The element that comprises the largest portion of the mass of the Earth's oceans is the largest portion, the largest amount, the biggest section. So obvious, oxygen. All right, elements in the human body. Wow, these are elements in my body. So let's read it. Humans, like all living things, require water to survive. The abundance of water in the body results in 3/4 of a human's mass being composed of. All right, well, you know what water's made of because we talked about it in class. And so it's hydrogen and oxygen, so you could probably already get the answer. However, we can use our math skills. We know 3/4. 3/4 is 3/4. That's 75%. So I guess if you know that 3/4 is 75%, then you can get it right. Like 3/4, like if you think about money quarters, 3 of them is 75. So oxygen is only 65. So let's look at the choices. Really, that's the way to do this. Carbon is it's between 15 and 20. So is that equal to 75? 3/4? Definitely not. Nitrogen all by itself, about maybe 4%. Definitely not 3/4, not 75%. Calcium and oxygen. Okay, so oxygen 65, calcium, I don't know, it's like 3 or 4. I'd say maybe, or probably more like 2 or 3. So if I take 65 and add 2 or 3, then that's like 67 or 68. That's not 75%. I don't like that. And then D, why does it keep getting covered up? D says calcium and it says oxygen and hydrogen, sorry. So that's 65 plus 10 is 75. So that's why D is the right answer. All right, Mrs. Brown was completing an inventory of the science supplies available to her students. Which column includes safety equipment? So you have to know what a column is. That's the up and down. So microscope, forceps, and gloves. Maybe you don't know what forceps are, but is the microscope safety equipment? B, goggles, gloves, and apron. C, apron, forceps, and goggles. Beaker, hot plate, and gloves. So let's say a student didn't know what forceps were. They know that a beaker and a hot plate are not safety equipment, so they could mark out D, big old X on your paper. They could mark out A because microscope, no, that's not it. So then we're going to do goggles, gloves, and apron. Most students would know what those 3 things are, and they would know that those are all safety equipment. They would go apron, that's safety. Forceps, I'm not sure. Goggles, that's safety. So if I was going to pick between B and C, I'd go with the one that's all safety for sure. And then forceps, I'm not sure. So it's probably B. But forceps is a fancy name for tweezers. If you use tweezers to pull out stickers that get in you, then that's what a forceps is. Anyway, B is the right answer. Miguel's lab group is conducting an experiment that involves dissolving different amounts of sugar and salt in test tubes. Which safety procedure is the most appropriate for this experiment? Shave your head bald to prevent hair in lab activity. That's a pretty hilarious answer. I can imagine a lot of bald-haired students, but I don't pick it because it's funny. Hold a scalpel away from the body to cut. It's dissolving things in a test tube. There's no scalpel, so that would not be good. Have a fire extinguisher near the table. Well, I don't have anything in here about fire or heating things, so I may or may not need a fire extinguisher. Wear safety goggles. Well, I'm using test tubes, so that's using glass, and I've got chemicals, even though sugar and salt are not really that dangerous. So I would definitely wear safety goggles. That's the answer, Jay. A certain element exists at room temperature as a dense solid with high luster, shiny. When tested, it conducts electricity. What class of element conducts electricity? Metals. B. So obvious. Metalloids, such as silicon and boron, always conduct electricity? No, that's metals. Always have metallic luster and are malleable? No, that's metal. And in fact, most of the metalloids are not malleable, are brittle and ductile. What? That doesn't even make sense. It breaks easily, but yet you can make a wire out of it? I can't even imagine what that would be. J, may contain characteristics of metals and nonmetals. Aha! That's the answer. It can have characteristics of metals and nonmetals, and that's why it's called metalloid. A certain element exists at room temperature as a brittle solid. Brittle means it breaks easily. When tested, it is a poor conductor. Poor conductor. So look, it breaks easily, but it's also a poor conductor. And that poor conductor clue is going to tell us that it's a non-metal. That's all. The whole review is done. Thanks for listening. Goodbye.